So we'll continue our practice for the hoop strain and the longitudinal strain. A closed cylindrical vessel contains a fluid at a pressure of 5 megapascal. The cylinder, which has an outside diameter of 2500 mm and the wall thickness equal to 20 mm. DO is given, DI is can calculate from the wall thickness. Length is given as 6 meter. Is fabricated from the stainless steel having Young modulus equal to 193 gigapascal, Poisson ratio equal to 0.27. Determine the increase in both the diameter and the length of the cylinder. We have given this time the pressure P that equal to 5 megapascal. It has a outside diameter, let represent as a DO is equal to 2500 mm and wall thickness is equal to T is equal to 20 mm. So let first calculate here the internal diameter DI. Internal diameter DI will be equal to D0 minus 2 times the thickness of the wall. We have D0 is equal to 2500 minus 2 times the thickness T, that equal to 20. So internal diameter is same as 2460 mm. Young modulus also given. We have E is equal to 193 gigapascal and Poisson ratio mu is equal to 0.27. Change in diameter we have to calculate. Change in diameter you can calculate from the hoop strain, that is epsilon D will be equal to change in diameter divided by original diameter equal to D, and the change in the length we can calculate from the longitudinal strain, which is equal to DL divided by L. So again we'll use here the state of a stress. Here we have the stress acting along the x direction is sigma x will be equal to the longitudinal stress equal to sigma L, and the stress acting along the y direction is same as equal to the hoop stress sigma h. The pressure is known, internal diameter is known, thickness is known. So let's calculate first here what is the hoop stress. So we have hoop stress sigma h is equal to pressure multiplied by internal diameter DI divided by 2 times of thickness T. Pressure is equal to 5 megapascal, internal diameter is equal to 2460 divided by 2 times of thickness. So we have 2 times thickness equal to 20. So we get the value of the hoop stress is approximately equal to 307.5, that will be megapascal, and the longitudinal stress is exactly half, that is sigma h divided by 2. 307.5 divided by 2 is 153.75. Again this value will be in megapascal. We'll use here generalized Hooke's law, and using the generalized Hooke's law we can calculate epsilon x. Epsilon x is same as sigma x minus mu times sigma y plus sigma z, and whole thing is divided by Young modulus E. We have sigma x here will be same as equal to the sigma L, and we have sigma y is equal to sigma h, and the sigma z will assign equal to 0. So let's substitute for sigma x. Sigma x is equal to 153.75 minus mu. We have mu is equal to 0.27 into sigma y. Sigma y is equal to 307.5. 307.5. Sigma z equal to 0 divided by Young modulus, which is 193 gigapascal. So divided by 193 into 10 to the power 3, and epsilon x is same as epsilon L, that is a longitudinal strain, and the longitudinal strain is same as dl by L. So we have dl divided by L, and the right hand side will give you the strain along the x direction, that will be equal to 366.45 into 10 to the power minus 6. We can write the unit as mm per mm, that is a dimensionless term. Hence we have change in length will be equal to 366.45 multiplied by 10 to the power minus 6, and we have given the length here equal to 6 meter. So you have to take that length in mm. So change in length we will get approximately is 2.2, that will be mm. Similar fashion, we can calculate the circumferential strain. So we need to calculate epsilon y. Epsilon y will be equal to sigma y minus mu multiplied by sigma x plus sigma z is divided by egg modulus E. Epsilon y is same as equal to epsilon h, and epsilon h is same as change in diameter to original diameter. So we can write epsilon y is equal to epsilon h, that is a circumferential strain. Sigma y is equal to 307.5 minus mu, Poisson ratio is 0.27, multiplied by sigma x equal to 153.75 plus we have sigma z equal to 0 divided by egg modulus, which one equal to 193 into 10 to the power 3, and the epsilon h is same as change in diameter. So we have change in diameter divided by original diameter. Right hand side we will get the hoop strength is 1378.14 is 10 to the power minus 6. Unit of strain we can write as mm per mm. And finally we have change in diameter equal to 1378.14 into 10 to the power minus 6, and we have to multiply by diameter. This time we will take the outside diameter equal to 2500. So change in diameter is approximately equal to 3.45, that will be mm. A long steel tube 7.5 cm internal diameter, 0.15 cm thick, has a closed ends. So if you have given the tube and the end is closed, then both the stresses will exist. If one of the end is open, then the longitudinal stress does not exist and is subjected to internal fluid pressure of 3 megapascal, Young modulus equal to 200, Poisson ratio equal to 0.3. Estimate the percentage increase in the internal volume. Since we are interested to know the percentage increase in the internal volume, that is, we are interested in the change in volume divided by original volume, which is same as the volumetric strain epsilon v, and volumetric strain epsilon v is equal to 2 times the strain along the diameter, that is the hoop strain, plus we have longitudinal strain equal to epsilon L. So procedure almost remains same. Let's collect the data first. Here we have internal diameter directly given here, internal diameter di, and we have internal diameter equal to 7.5 cm multiplied by 10, that will be equal to 75 mm. Thickness is 0.15 cm, so we have thickness T equal to 0.15 multiplied by 10, that equal to 1.5 mm, and the pressure P is equal to 3 megapascal. So we have pressure equal to 3 megapascal. Young modulus and mu is given. In the case of thin cylinder, the stress along the x direction is a longitudinal stress and stress along the y direction is hoop stress. We know the pressure P, thickness and the internal diameter, so we can calculate here the hoop stress sigma h, which is given as pressure multiplied by diameter di divided by 2 times of thickness. Here we know the value of pressure is equal to 3 megapascal, internal diameter equal to 75 is divided by 2 times the thickness, and we have thickness is given as 1.5. So we'll get the value of the hoop stress sigma h. 3 and 3 will cancel, so we have hoop stress is same as 75 megapascal. Half of this value will be sigma L. So we have sigma L will be equal to sigma h divided by 2. That will be equal to 37.5. 75 divided by 2 is 37.5 megapascal. If you remember, the volumetric strain is well and good, otherwise you can go by basic principle. So sigma h is acting along the y direction, that value will treat as sigma y, and the sigma L is acting along the x direction. So we have sigma x will be equal to sigma L. We can apply here the generalized Hooke's law in the x direction, that is epsilon x, we can calculate from sigma x minus mu, sigma y plus sigma z. Sigma z you can force equal to 0 divided by Young modulus E. Sigma x here will be equal to 37.5. So we have 37.5. Poisson ratio equal to 0.3. Sigma y is equal to 75. Sigma z equal to 0. And epsilon x is same as the strain along the longitudinal direction, that is epsilon L. Young modulus we have to take as 200 gigapascal is 200 into 10 to the power 3, that will be megapascal. So the strain along the longitudinal axis epsilon L come out to be 7.5 into 10 to the power minus 5. We can write the unit as mm per mm. Similarly, we can calculate the strain along the y direction, that will be sigma y minus mu times sigma x plus sigma z divided by E. The strain along the y direction is same as the hoof strain epsilon h, and we have sigma y is equal to 75 minus Poisson ratio mu, that equal to 0.3. Sigma x is sigma L, that is equal to 37.5, and sigma z equal to 0. Divided by Young modulus equal to 200. Megapascal is 10 to the power 3. In this case, we have circumferential strain epsilon h is equal to 3.18 into 10 to the power minus 4. And unit we can write as again mm per mm. So we can very well calculate here the change in volume upon original volume. So we have change in volume upon original volume is 2 times of circumferential strain, that equal to 3.18 into 10 to the power minus 4, plus we have longitudinal strain, that is 7.5 into 10 to the power minus 5. So we have dV by V, change in volume upon original volume, is equal to 7.125 into 10 to the power minus 4. And we are interested in the percentage increase. So dV is positive value, so we'll write here the percentage increase in volume is given as dV by V is multiplied by 100. So this value you have to multiply by 100 will be equal to 0.07125, that will be percent. So multiply by 100, you will get your answer as 0.07125. So we have practiced up till now the conventional question. Now we will practice here the gate type of questions, that is 2-step questions. Circumferential stress, that is a hoof stress in a cylindrical steel boiler shell under an internal pressure is 80 megapascal. Directly we have given the value of sigma h equal to 80. Young modulus and the Poisson ratio are also given. The magnitude of circumferential strain in the boiler we have to calculate. So the question is of 1 mark or 2 mark. Keep your steps standard. First you draw the state of a stress. Sigma x is same as sigma L. Sigma y is equal to sigma h. And this value of sigma h is known to us, that equal to 80 megapascal. And half of it will be sigma L will be equal to 40 megapascal. And the stress along the z direction will be equal to 0. What we are interested to calculate the circumferential strain, that is the value of epsilon h we have to calculate. Epsilon h is same as epsilon y you have to calculate. So apply the generalized Hooke's law along the y direction, which is given as sigma y minus mu, sigma x plus sigma z divided by Young modulus. Epsilon y is same as equal to the circumferential strain epsilon h. Sigma y is equal to 80 megapascal. Mu is equal to 0.28. Sigma x is equal to 40 and sigma z you have to make equal to 0. Divided by Young modulus, which is directly given in megapascal, is 2 into 10 to the power 5. So very straightforward questions they will ask you on the basic equation, that is the generalized Hooke's law. So you will get here the circumferential strain epsilon h is close to 3.44 into 10 to the power minus 4, and we have same conversion it as mm per mm. 3.44 10 to the power minus 4. Our choice is correct choice. A welded steel cylindrical drum made of 10 mm plate and internal diameter of 1.2 meter. Compute the change in diameter. Change in diameter we can calculate from the hoop strain. That would be caused by an internal pressure of 1.5 megapascal. Assume that the Poisson ratio equal to 0.3 and Young modulus equal to 200 gigapascal. We know that here the hoop strain is same as equal to the diametral strain, that will be equal to the change in diameter divided by the original diameter d, and the hoop strain will be same as epsilon y. So you need to calculate here epsilon y. Thickness is given as 10 mm and the internal diameter equal to 1.2 is 1200 mm, and the internal pressure P is given, that will treat as a gauge value is 1.5 megapascal. In addition to this, we have given the Young modulus and Poisson ratio. For all the problem, you always make a standard procedure. First, draw the state of a stress. We have sigma x equal to sigma L, sigma y is same as the hoop stress, and the stress along the z direction equal to 0. We know the value of pressure, we know the diameter d and the thickness t. So let's first calculate what is the hoop stress. Hoop stress is represented by sigma h is given as the pressure multiplied by internal diameter d and is divided by 2 times the wall thickness t. Pressure here you have to use in megapascal is 1.5. Diameter you have to use in mm is equal to 1200 mm divided by 2 times the wall thickness, that equal to 10. So we have 1200 divided by 20 is 60, 60 into 1.5, that will be equal to 90. So we get the hoop stress equal to 90 megapascal, and this value you have to treat as sigma y value. Sigma L is exactly the half of the hoop stress. So we have 90 divided by 2, that equal to 45 megapascal, and this value is acting along the x direction. We need to calculate here epsilon h. Epsilon h is epsilon y. So we have epsilon y is equal to sigma y minus mu sigma x plus sigma z divided by e. Epsilon y is same as epsilon d and is same as epsilon h is change in diameter divided by original diameter. So we have change in diameter divided by original diameter. Stress along the y direction is equal to 90 minus mu. Mu is given as 0.3. Stress along the x direction equal to 45. Stress along the z direction is always equal to 0. Divided by Young modulus, which is equal to 200. You have to use this value in always megapascal into 10 to the power minus 6. And if you multiply by diameter, we can calculate here the change in diameter. This time we have diameter d is equal to 1200. So we'll get here the change in diameter, that will be approximately equal to 0.46 mm. A closed-end thin wall cylinder of original length L, thickness T, internal radius R is subjected to internal pressure P. Find the minimum principal strain, and we have given the value of Poisson ratio equal to 1 by 3. All answers are given in the form of R. We have a hoop strain will be equal to P into R divided by T. Make your steps standards. First you draw the state of a stress. Sigma x equal to sigma L, sigma y is equal to sigma h, and sigma z equal to 0. The strain along the longitudinal axis will be minimum and the strain along the circumferential direction will be maximum. We are interested in the minimum principal strain. It means that we have to find out the value of epsilon x. Since the all answers are given in the form of R, so we'll use the formula for sigma h, that will be equal to P multiplied by R divided by T, and we have sigma L will be equal to pressure multiplied by R and is divided by 2 times of T. Sigma h is acting along the y direction and the sigma L is acting along the x direction. The strain along the x direction is a minimum value, that is the longitudinal strain is a minimum value is sigma x minus mu times sigma y divided by E. We have sigma x is equal to sigma L. So we have sigma L minus mu times sigma y. Sigma y is sigma h and sigma h is 2 times of sigma L. So we have 2 times of sigma L and this whole thing is divided by the Young modulus is equal to E. We'll take out here sigma L common. So we have sigma L 1 minus 2 times of mu is divided by Young modulus E. Sigma L we can write as P into internal radius R divided by 2 times of T multiplied by Young modulus into 1 minus 2, and we have mu is equal to 1 by 3. 1 minus 2 by 3 is 1 by 3. So we'll get here 1 by 6. So we have minimum strain will be equal to pressure P multiplied by R divided by 2 into 3 is 6 times T multiplied by E. PR divided by 6 times T, choice B is correct. So this one is the minimum principal strain. The video you are watching is from the app, which is the Mohod class app available on Google Store, and in this app we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.